Just wait for 5 minutes so others can join, and then we will start the session. Okay, I hope my screen is visible. Please give me thumbs up so I can start. Come on, hurry up. Am I audible? Aryan, Namrata. Okay. Very good. Aman is and now. Aman, my screen is visible to all of you. Is my screen visible? Again, give me thumbs up. Anyone out of you? Okay, Aryan. Okay, thank you very much. So, in the morning session, what we have covered, so, corporate data center. We discussed a lot regarding what is the corporate data center. Now, let's begin with the data center topologies, where we basically going to discuss about layer 3 and layer 2 design. Okay, so now we move to an important topic in data center design, which is the data center topology. Specifically, we are going to discuss layer 3 and layer 3 and layer 2 designs. Okay. So what is mean of data center topology? So when we talk about the data center topology, so topology generally topology refers to how the different network devices are connected and organized inside the data centers. So it defines the how servers communicate, how data flows, how scalability performance are achieved. So this kind of things we can define in a topology. Okay. Now here we are going to discuss about the layer 2 and layer 3, 3 basic first, and then we will discuss about their topologies too. So typically, data center use the combination of layer 2 and layer 3 technologies. So what is mean of layer 2? So there comes the basically switching. Okay, in the layer 2, there comes the switching. So we works using the MAC address. In layer 2, generally we works using the MAC address used for the communication within the same network, and that is basically supports the VLAN and fast switching. So we commonly use that the access layer. So layer 2 comes at a access layer where server connectivity happens. Now what is mean of layer 3? So when we talk about the layer 3, there comes the routing. okay, which basically work using the IP addresses. Okay, in layer 2 we works with the MAC address, and in layer 3 we works using the IP address. It is generally used for communication between different networks, okay, it provides the routing, traffic control, and it commonly used at the aggregation and core layers. So I hope you understand what is mean of layer 2. So when we talked about the layer 2, there comes the switching, and when we talked about the layer 3, then comes the routing. So why combination of layer 2 and layer 3 are required? So very simple, using both layers together, which provides the efficiency, scalability, flexibility, and reliability. Okay, so when we say the efficiency, there comes the fast local communication, and that we achieve using the layer 2. When we talked about the scalability, so where that means the better network expansions we can perform, and that we can achieve through the layer 3. And when we talked about the flexibility, it supports the different applications. And reliability means that the control traffic flow over the networks. Okay. So generic server farm uh, uh, topology, we already saw the figure 4.6. So when we talked about the generic topology shown in the figure in previous figure, which represents the multiple servers connected through the switches. Okay, and there comes the layered architecture like the access layer, aggregation layer, and core layer. This layer architecture we already discussed in unit number second and third two. So this design generally supports the large number of servers with the efficient traffic management and easy scalability. So what are the key advantages of this design? It is easy to expand server farms, and it supports the high availability, and also improves the network performance, and the most important thing, it enables the load balancing and redundancy. So I hope you understand what is the mean of what is the importance of layer 2 and layer 3 in a data center topologies. We can take the real-time examples like the cloud data centers, AWS or Azure, any one of this. They use layer architecture and combine the what we can say. So this kind of AWS, and they use the combined architecture, or you can see the layer architecture, and they combines the layer 2 and layer 3 for this scalability. And another real-time example, you can say the large enterprises where the internal application runs on the layer 2, and routing between the department handled by the layer 3. Okay. So this is again the very most important thing. So what we can say about this, the layer 2 and layer 3 generally designs together, its designs together forms the backbone of the modern data center topology, and which ensures the efficient communication, scalability, and high performance. Okay. So here, this is what a 4.6 figure. We already discussed about it, but in the different form of. So here we have the core layer, aggregation layer, access layer, and all these things. Okay. So this is what generic server farm design, where we use the layer 2 and layer 3 um, uh, architectures. Okay. So let's understand this diagram, which shows the generic server farms topology used in data center. So this is generic server farms design. Okay. So at the top of what we see the IP network, which represents the external networks core network connectivity. This IP network, and below that the design is divided into two major layers. Okay, so it is design divided into the two major layers, like a aggregation layer, and the second one is the access layer. So this is what aggregation layer, and this is what access layer. So this layer approach generally helps in the better management, scalability, performance optimization. So let's discuss first the aggregation layer. That is the top layer. So this layer contains the multiple switches like layer 2 and layer 3. For example, we can say the aggregation 1, aggregation 2. So these switches perform the routing at the layer 3 between the networks and switching at a layer 2 within the networks. Okay. So what is the key responsibility of this aggregation layer? It acts as a gateway for the servers. It handles the traffic control and routing decisions. Also, it connects the external network, or you can say the IP network. So this is a critical control layer again. This aggregation layer is a critical control layer, and that we already discussed in the previous two units. Then comes the access layers, and that is the bottom layer of this generic server farm design. Uh, this this access layer includes the layer 2 switches. So this is what access 1 and access 2. So these are two layer 2 switches, and this switches provides the direct connectivity to server. These switches generally provide the direct connectivity to whom? Server. And this means like the what basically connected to this access layer, like the generic server or database server, mainframe system, servers with the internal and external storage. So these are the components that include when we say the layer 2 switches are connected. What is the key responsibility of this access layer? So it generally it mostly help us to connect with the servers to network and handle the local traffic switching. Also, it provides the high port density. So this is the server facing layer, mostly what we can say. So this is what server facing layer. Okay. Here we have the connectivity between the different layers. So aggregation layers are connected to the access layer. So there are the redundant connections also, and which provided the multiple path to communicate with that different layers. So this generally ensures, this complete diagram ensures the high availability, load balancing, and no single point of failure. Okay. Mostly the key highlights of this topology is like aggregation switches performs the both layer 2 and layer 3 function. So when we access the switches that provide server connectivity, so strong connectivity between layers ensures the performance, reliability, and scalability. Okay. Okay. So what is the relations in this type of things in a data server? So again, we can say the scalability, high availability, performance, and flexibility. Okay. So some real-time examples, you can say the cloud data center, which uses the aggregation for the routing and access layer, which help us to connect with the thousands of servers. Okay. So this generic topology forms the foundation of modern data center, which basically combines the layer 2 and layer 3 functionalities for the efficiency, scalability, and reliability server from deployments. Okay. Now let's discuss these two layers, that layer 2 and layer 3 in detail. Okay, so what are the layer 3 functions? So now let's focus on the layer 3 functions performed by the aggregation switches. Okay, so which are very important in data center topology. So first, what we can say, the forwarding, packet forwarding. Okay, this is the layer 3 routing. When we talk about the packets forwarding, so there comes the layer 3 routing. Okay. Uh, the aggregation switches are mostly responsible for the forwarding the packet based on IP, where layer 3 informations. Okay, so what does this mean? The data combined from the server is routed to the other networks, or you can say the internet or other data center segments. So unlike layer 2 switching, which use the MAC address, layer 3 use the IP address to decide the path of the communication path between two client and server relation. So this ensures the efficient communication between the different networks and the proper traffic flow across the data centers. Okay. Second functionality that maintains the dynamic network view. So here the aggregation switches maintain a view of the entire network. So that basically includes the routing table, network path, and available routes. Okay. So this view is a dynamic, means it updates automatically when the network changes. Any changes occurs in a network. For example, link failure, network, any network we have that is added by the someone else. So the system adapts quickly without the manual interactions. Okay, and this layer C generally supports the default gateway for the server farm. So again, the here the aggregation switches act as the default gateway for the server. So what does that mean? When the server wants to send the data outside the network, it sends the traffic to the aggregation switch. Okay, then the switch decide where to forward the data. So this is the critical functions because the all external communication between any external communication between on it that will be happen successfully. So why these functions are important? Mm, These three functions like forwarding packet, maintaining view, and supporting the default gateway. This function, why these functions are important? That's so important. So this layer three function ensures the scalability, reliability, and efficient routing. So everywhere you are getting this kind of scalability, reliability, and efficient routing performance. So when we talk about the scalability, it suppose the large networks. Reliability means adequate failures, and efficiency. When we talk, that is the optimal data flow comes over there. Okay, there are a lot of real time examples where we can see the cloud data center, the e-commerce platform, and any enterprise networks. Okay, so so what we can say about this, like aggregation switches plays a very what we can say the crucial role by the performing the layer three functions such as routing, maintaining network, and awareness, and acting as a gateway for the server communication. Okay. Now let's discuss about the layer two functionality in aggregation switches. So again, uh, let's understand the layer two functions performed by the aggregation switch. So which are the essential for maintaining a stable and efficient network. So here, I hope you are aware about the spanning tree, which we learned in the data structure. Okay. So let's see how this spanning tree protocol. So same similar types of spanning tree protocols we work. It works in a network. So in a data center, we have the multiple redundant links to ensure the availability. So, however, these multiple paths can create it like the network logos. So loops can be caused like broadcast storm, network congestion, and system fails. So to prevent these kind of things, we use the spanning tree protocol, STP. Okay, so it provides this as we 23. Sorry. Okay. Uh, what we can say this prevent that we use the spanning tree protocol. It prevents the STTP creates loop free topology by the blocking the redundant path and allowing only one active path. Okay. When we talked about the STP enhancement, so this is what your STP enhancement. So the basic STP like a 802.1D is slow. So enhancements are used to improve its performance. So what we can do, so we can use the 802.1 So rapid STP that we can say, okay, which faster uh, converges and reduce the downtime. And if we talk about the STP 802.1 S, 802.1 S, so it supports the multiple virtual LANs efficiently. Okay, which help us to another one is the uplink fast and backbone fast. They improve the recovery time during the failures, any kind of failures occurs. Okay, so uh, what we can say that is a loop guard. Here is one loop guard. So that loop guard prevents the loop due to the link failure. So this enhancement make the network faster and more reliable. When we talked about the VLAN for the logical separation of server farms, this means the different application or different departments are isolated and improves for the security and performance reason. Like for example, the web server is the when we talk about the web server is one VLAN and database server is another one. Okay. And the last, what we can say, the additional layer 2 services that aggregation switches also supports. The first one is the multicast, second one is we can say the access control, the third one is the quality of service, fourth one is the rating limit, and fifth one is the broadcast suspension. So these are the um, basically aggregation switches also support for the same. So what is meaning of multicast? Where we efficiently deliver it to the multiple users. Any data we have that we deliver to um, any data centers, okay, or users, multiple users. What is meaning of ACL? Where we control which traffic is allow or block. Okay, uh, QoS when we talk about the quality of services and all these things like that. So why layer 2 functions are important? So most important thing because the basic reason because um, these functions ensure the loop free network. Second, these functions perform the better performance, security and controls, and efficient traffic management. So that is why the layer 2 functions are really important for that one. And if we talk about the real life examples, so we can say the video streaming like the Netflix, enterprise network like VLAN, separate HR and finance and IT department. Okay, so at last, what we can say the layer 2 functions in aggregation switches that ensures stable, secured, and efficient network by preventing the loops, separating the separating and managing the data flow efficiently. Okay, so that's it for the layer 2. Now, what is the access layer switches and server types over here? So uh, let's understand this one. So the role of access layer and switches in data center is like this access layer is the closest layer to the server. Any access layer is the closest layer to a server directly. So its main function is what to provide a direct connectivity to all servers in the server farm. So what does that mean? So all servers are physically connected to the access switches. So it acts as an entry point for the every server's communications. Okay, so there are types of servers in a server farms like DNS, that is domain name system that converts the DNS name into the IP. Then comes the DHCP. So when we talked about the generic DHCP, so this is what is dynamic host configuration protocol, which assigns the IP automatically, dynamically. Third, what we can say the FTP, that is file transfer protocol. It helps us to transfer the files. And sorry, last one is that is telnet, where we perform the remote login. So these are the basic network services we service providers we have in the market. Okay. Now, what about the mainframes? So it is a high performing computing system, which is basically used for the large scale processing enterprise applications. So this may use uh, SNA over the IP or standard IP based communications. Okay. Now the database servers. Okay, where it is store and manage data and critical for the application transaction business operation. So these are the most important servers in the many server system. Okay, so there are different types of storage types in the servers. Okay, so server can have the two types of storage. First one is the internal storage and second one is the external storage. So internal storage will decide the server, uh, which includes the hard disk, tape unit. So simple and directly connected. Okay. Then comes the external storage and internal storage. So when we talk about the external storage, it connect outside the particular server. Typically, it used for the small computer system interface. Okay, which is basically used for the large storage needs and better scalability. Okay, so there are some importance of the this access layer switches and server types. Okay, like this access layer ensures the high speed connectivity, efficient communication between the servers, and it supports the different server types and what we can say the storage system. Okay, so the access layer plays a critical sorry, this access, what we talking about the access layer. So this layer, whatever access layer we have, the aggregation, sorry, access layer we have, that critical role by the directly connecting the various types of the servers and which ensuring the efficient communications and data handling within the data centers. Okay, uh, sorry. Uh, Now, here we are going to see the connection between the aggregation layer and access layer. Okay, so let's see how how the connectivity is established between the aggregation switches and access switches and the server in data centers. So first point is like Ethernet channel between the aggregation switches. So this is what Ethernet channel between aggregation switches. So let's first look at the connection between the aggregation switches. So they are connected using the Ethernet channel, and that Ethernet channels combines the multiple physical links into one logical links. So what we can say, when it increases, like the bandwidth and reliability increases. So these links operate by trunk mode, which means they can carry multiple virtual LAN or the single connection. So it supports up to the 4096 VLANs due to the 12 bits VLAN ID. So this ensures the high capacity, efficient data, uh, what we can say the efficient data flow and all these things. Okay. Now, what is mean of uplink? So that is what access from aggregation. So uplink, sorry, access to the aggregation switches. So let's look at this the connection from uh, from access switches to the aggregation switches. So these are called the uplink. Okay. So they can be single links for the traffic. Okay, they can be what I'm saying. They can be single links for low traffic and multiple links or ether channel for the high traffics. So these uplinks also use trunk mode, meaning what we can say about it, when the multiple virtual LAN can pass through the one physical connection. So this provides the scalability flexibility and efficient use of the network resources. Okay. The next points, what we can say, the server dual homing. So this is what a server dual homing, where now let's focus on this one. The servers are connected to the two different access switches. In server dual homing, what happens? The servers are connected to the two different switches, two different access switches. So this is called the dual homing. So each server has the NIC. NIC stands for Network Interface Card with the two ports. So these ports works in a active and standby modes. So one port is active, the other is a standby. There also one mechanism that is a failure mechanism. So if the active link fails, the standby port automatically what we can say takes over it or it use the name like MAC address and IP address. So from the network perspective, there is no interruptions. So what is my next question? Why this important? Okay, well, why these things are important? So you can say the this connectivity ensures the high availability, load balancing, scalability, and redundancy. Okay. Next slide. The need for the layer 2 at access layer. What is the need for the layer 2 at access layer? So very simple. So why layer 2 switching is used at the access layer in data center? So that time what we can say in traditional use of the layer 2 at the access layer. So access switches have the traditionally been the layer 2 switches, meaning they operate using the MAC address, which provide the fast switching within the same networks. Okay, so this design is also commonly used. This kind of designs are also commonly used. Now, what are the similarities? Data center has some similarities and some unique requirements. So when we talk about the similarities in campus network, so we can say that in this campus network, the access switches connect to the device like the computer, printers. Similarly, in data centers, the access switches operates or access switches connects to the server and storage systems. So the basic functions remains the same, which provide the direct connectivity. Okay. Why layer 3? Okay, so why layer 3? So when we talked about why layer 3 is prefer at access layer, so you can say that layer 2 is used because it provides the fast communication and simple design. Very simple answer for that one. And also it is a efficient server communication over there. So data, so here what we can say the data service centers versus the campus network. So although both are similar, that data centers have the unique requirement like the higher performance needs. Uh, what we can the more traffic between the servers require the high speed switching, scalability, large number of servers. So these are the points what we can say in terms of the layer 2. So what we can say, so with while the layer 2 is used, it enhanced with the VLAN redundancy and advanced feature. I hope you understand the road of VLAN. Sorry, layer 2. Layer 2 at the access layer, it provides the fast, simple, and efficient connectivity that makes it an ideal chronic for the or any kind of it makes it an ideal choice for the servers communication in data center. Okay. Next, what we can say the reason for the layer 2 access layer, layer 2 at access layer. So the main reason, what is the reason behind that? What why we are using the layer 2 at access layer? So let's understand the main reason why layer 2 is used at access layer in the data center. So first we can see the server grouping that concept. So in data center, servers are oftenly grouped based on their functions for example, FTP servers, file servers, and database servers, or the database on dependent ownership. Okay, so these groups serves are placed in the same VLAN communication. So why the same VLAN again? So when server are in the what I can say, servers, whenever server are in the same VLAN, they belong to the same subnet. They can communicate directly to using the layer 2 switches. So this basically ensures the faster communication and low latency. When we talked about the server to server communication, many application requires the request communication between the servers. For example, web servers to the web application, web application server to the database server. So this communication is faster when the servers are in the same subnet. That is what at a layer 2. Okay. Clustering protocols. This is what the heartbeat of the communication. In advanced systems, server work in a cluster, and cluster servers that continually exchange the single signals called the heartbeat messages. So these messages are what we are seeing that monitor serves the health and ensure the failure supports. Okay. Why layer 2 is necessary? So again, what we can say, because some communications like it requires the same subnet and cannot be routed. So layer 2 ensures that the direct communication, compatibility with the cluster protocol, and efficient application performance. So these are the why we choose the layer 2 at the access layer. Okay. Now, what is the additional reason for the layer 2 at access layer? So dual homing, that we already discussed, dual homing server for the redundancy, horizontal skill. Okay, again, let's discuss these things one more time. So uh, now let's look at some advanced reason why the layer 2 is required at the access layer in data center. This is a very important point. So here the first point, what we can say, the dual homing servers, where the redundancy are comes. So servers are usually connected to the two, uh, connected to the two different access switches. Okay, so this is called the dual homing. So it ensures the high availability on single. Uh, wait, wait, sorry, I thought I forgot to unmute, but it's mute unmuted already. That's fine. So I hope you understand what is meant of dual home, where servers usually connected to the two different access switches. So that is what a dual home servers for the redundancy. Okay. Why? Because when the failure happens, standby interface takes over and use the same IP address and MAC address over there. So this is a seamless transition is only possible in the layer 2 environments. So keep this in mind. The next one is the horizontal scaling for the server farm, where the data center grows horizontally, means the new server are added alongside existing one. So new servers must be the place in the same virtual LAN, or you can say the subnet, as the servers performing the similar operations. Most of these time servers perform the similar operation. So if one switch runs out of the port, the new switch are added to the same VLAN is extended to the new switches. So this again ensures that the flexibility, easy expansion, and no need to redesign the network. Okay. Next, why additional reasons? So that supports the stateful devices. Okay, so data centers use the devices like the load balancer and firewall. So these are called the stateful devices. Okay, so why layer 2 is important for the stateful devices? So you can say the stateful device that track the session, connection information, and it basically requires the inbound and outbound traffic to follow the same path. Okay, So what we can say about this slide? So this layer 2 at the access layer is essential to ensure the redundancy, scalability, and proper functioning of the stateful devices in modern data centers. Okay. What is next? Let me check the time. Okay. At 10:50, sorry, 7:50, I have another session. So, okay. Multi-tier design. So let's discuss about what is the multi-tier design. I hope in previous session also we discuss about the multi-tier design. Okay. So let's understand the concept of the multi-tier design, which is widely used in modern data centers. So yeah, suppose application models we have the most of the application follows either the client server model or entire architecture. Okay, so what is the client server model? It is very simplest architecture where the client communicate directly with the servers. No interference between the communication or no other mediator in between the client and server. So where the clients directly communicate with the server or some other ones. Okay, what is mean of entire architecture? So here we have the more advanced and scalable entire architecture where applications is divided into the multiple layers or tiers. Okay. Next one is some that is what the common tiers. Yeah, like the client, web server, application server, and database server. So is this the common tiers uh, in data center typically includes the client where we say the user devices like which is having the browsers and app. When we talked about the web server, there comes to handle user requests generally, mostly where we have the landing page of any websites and applications. Then comes the application server where we actually write the business process the business logic. And the last one is the data where we store and manage the data. Okay, so each tier performs a specific functions, making the systems modular, scalable, and easy to manage. Okay, uh, so how the communication between these tiers happen? So this tier must communicate with each other. For example, client to web server to application server to at last the database server. It will communicate like that. So this design depends on how these tiers are communicated. Okay. Uh, uh, what we can say load balancing implementations. So when we talked about the load implementation parts, where network services we use to meet this kind of requirement, data center use the load balancing, like where we distribute the traffic across the multiple servers, and it improves the performance and availability. Then comes the SSL encryptions, and that is the secure mode, very secure communication layer, where we use the secure socket layer, where encrypt data between the tiers and ensure the security transactions. The last one is the firewalls and IDS. So we know that what is the firewalls and IDS, which is the protection between the different layers. Okay. So what we can say the multiple tier design is essential in modern data center to build this scalable, secure, and a high performance application by separating the functionality into the different layers. Okay. So this is all about the multi-tier designing. Let's see the multi-tier application environment. So this is the what diagram, uh, which shows the multi-tier application environment. Okay, so let's understand the diagram which shows the multiple tier application environment in data center. This is again very important architecture used in the modern applications. The first one is the IP networks. Again, I discussed many times what is the IP networks and how it works. So it is always come at the top layer. So at the top, see always we see at the top of the any uh, environment. Um, this IP network generally represents the internet, external users, and client devices. So all user requests initially originate here only. Next comes the aggregations layer. So this aggregation layers contains the multiple switches like the L2 and L3, layer 2 and layer 3 switches, which handle the routing and traffic control. And it acts as the gateway between the external network and internal server layers. Third one is a front end. That is front end layer that we can call it a web servers. So the first point of contact for the users, these are the landing page, which is basically first point of contact for the users, like HTTP and HTTPS request, web page, and all these things come for here. Next layer is the applications layer. It contains the application server where its responsibilities like it help us to execute a business logic and data processing. So, for example, we can see the processing the login of any user and handling any kind of transactions that happen through the client or any bank account holder. Okay. Last, that is the backend layer, which is at the bottom. So we have the backend layer that contains the database servers, and it is mainly responsible for the data storage and retrieval. So we can see the example like storing user data, fetching product details. These things to be performed with the backend layers, and where we actually your database servers are there. And the sixth one, we can see the flow of communication. So let's understand the flow. User sends the request to the web server to the application, and application to the database. So each layer perform a specific task, and responses uh, 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 several reverse path. Okay. Uh, what more you can say about this diagram? So what is the redundancy in this diagram? So you can see the multiple switches and servers across the connection. So this ensures the high availability and no single point of failure over here. Okay. So what we can say about this diagram? So it is a multi-tier architecture, divides the application functionality into the layers, which ensuring the scalability, security, and high performance in the modern data center environments. Okay. So that's it for today. We will discuss this diagram, that is 4.10 and 4.11 upcoming sessions or in a one day session. Okay. So let me start the what is that attendance. Okay. For attendance. Okay. Can I unmute 25 participants? Let's see how can unmute all of you. Okay, now you can unmute yourself. I hope so. Yes. So unmute yourself and give me your attendance. Okay. So uh, just call your number 1 to 5.
Roll number 1.
Good. Next.
Roll number 4.
Sir, roll number 2.
Roll number 2
Roll
is
number
there.
4.
4 is also there. 5 is also there. Okay. Next. 6, 7. 6, 7.
Roll
6 or 7.
Sir, roll number 2 present.
Roll number. Sorry.
6, sir.
6 present.
Yes.
7.
8 present,
Okay,
sir.
8. Sorry,
8 present, 8.
8 present. Okay, Ashish. 9, 10,
10 present.
11, 10 present. 11,
11 present, sir. 11
12,
present.
12, Gaikwad. 13, Harsh. 14, 15,
15 present, sir.
15 present. 16, 17,
17 present, sir.
18,
18 present, sir.
19. Hurry up, please. 20, 21, 22, 23,
23 present, sir.
21, and 23 is present. Okay. 25,
Sir, 24 present. Sir,
24.
25 present.
Ruturaj present. Okay. Next, 26.
Yes, sir.
Sir, 26
26
present.
present. Very good. 27, 28, 29, 30, 31, 32,
30 present, sir.
Present, sir.
30 present.
30 present.
3 present.
Sir,
Sorry,
31 also present.
31 present, 30 present. Next, किसने बोला था बीच में?
33.
33. Okay. 34, 35, 36, 37. Don't text
37 present, sir.
me. 38, 39, 40, 39 present.
39
30,
present. Harshdeep.
हाँ हाँ झालं बेटा. 40, 41,
41 present, sir.
41 present.
Sir, have you marked 24?
Sorry. Yes.
Sir,
24
24.
मार्क कर दिया. हाँ हो गया बेटा 24.
Sir, have you marked 13?
13. हाँ ये no. Harsh.
Yes, sir, roll number 13 present.
Okay, done. Anyone else?
So roll number
Don't
37
text me.
present.
37. अरे यार हाँ हो गया ना भाई तेरा. चलो और 2 बच्चे ने अटेंडेंस नहीं दी है. ओके दैट्स फाइन, वो उनकी चॉइस है. हैव अ नाइस डे.